Section 3.2, solving linear systems algebraically. In the last section, we solved a system of equations, linear system, by graphing two lines. So the three cases where one line intersected another line, and you had a single point with an xy coordinate value. One solution. The other possibilities, one was the two lines are parallel, they never meet, and they are no solutions. Third one were two lines that were parallel and of course right on top of one another, the same equation, yielding infinite solutions. Well, today we're going to solve similar kinds of problems, but algebraically, not graphing. First one is substitution method. 3 steps. First, we're going to solve one of the equations for one of the variables. Again, you look at the first example, you have two x's, two y's, pick one. And we'll show you what you got to do to pick the easiest one. Step 2 is to substitute the expression from the first step into the other equation. And then that will yield one answer for one of the x or the y, whichever one you were isolating. And you'll substitute that into the other equation to find the second variable. Well, it's much easier to just show you all that. So let's get going on the first example. I look at those two equations and I try to figure out which x or which y is easiest to isolate. And this one should stand out for you. This x plus 3y equals 3. I'm going to try to isolate that x. So I'm going to solve for that x on this equation. So you subtract 3y from both sides, and you get x equals 3 minus 3y. Okay, and that is a quantity. I like to use parentheses to show that this whole quantity equals x. That's step 1. We solved one of the equations for one variable. Step 2, substitute the expression from step 1, that's this thing, into the other equation. Well, here's the other equation. We didn't touch this yet. Well, we have x equals this quantity. Let's go to the x right here, kick it out of there, and put this quantity in its place. So for step 2, substituting this for x, because x equals that in the second equation. So here goes. So I'm going to rewrite this for you as it was. 2x plus 5y equals negative 5. Again, x equals this quantity. That goes in place of the x. So I have now 2 3 minus 3y. And that's going to be plus 5y. Don't forget the rest of the equation. Now, that was step 2. We substituted this into the second equation. And now the entire equations combined has everything from these two equations in terms of one variable, which we can solve for. So let's go do that. So 2 times 3 is 6. 2 times negative 3 is negative 6y plus 5y equals negative 5. So we have now, see, negative y, so 6 minus y equals negative 5. I subtract 6, I get negative y equals negative 11. You know we can't have a negative, here, so we multiply both sides by negative 1, we have y equals 11. That's half of an answer, the 11 for y. All right, so that's step 2 completed. Step 3, substitute the value from step 2, that's this value, into the revised equation from step 1. Well, here's a revised equation, because look, it's going to give us x. We put this in for y, we get x. That's what we want, the x and the y. That's the point where the two lines here will intersect. So putting the 11 over here, we have x equals 3 minus 3 times 11. X equals 3 minus 33. Combining that, x equals negative 30. So there's our point. Negative 30, 11 is where this point is the point where these two lines meet. Now, that's a big number, so you wouldn't want to graph that. That's why the algebraic method sometimes pays, because things are a little more contained in a large graph. Let's try another example down at the bottom. Number 1. Now, again, you're not going to see a whole lot of paper here, of course. You get your own paper. Mr. E has some paper up front on the demo desk. Help yourself to that. So the first one here at the bottom Now this one has, let's see, I'm going to try to find one that's a little different for you, because that has x already, and we did x. So let's go to, just to show you that you can pick any of the letters. I want to pick, go to skills practice on the back. Number 4 has a y. For the variable you want to pick and have it by itself, I like that y. So let's solve for that y. So 3x plus y equals 16. Get it by itself. Subtract the 3x from both sides. Y equals 16 minus 3x. Again, parentheses. Isolate it. That should show you that the y is equal to the quantity 16 minus 3x. You know, kind of keep track where you're going up here. I did this equation. I'm going to put a check mark there, knowing I'm done with that. So now I got to go to this one. Well, this y is going to come out, and this is going in its place. So I'm going to rewrite this equation for you as 2x minus 3y. I'm going to write it as it is already, equals -4. That's this equation. Y equals this. Well, here's y. I'm going to take it out and put this in its place. So 2x minus 3. Now the y is gone, and 16 minus 3x takes its place. Okay. Now don't forget the rest. I have equals -4. Just make sure, take a moment here to make sure you got the whole equation represented. This whole thing was the x, was the y over here. This took its place. One variable now. You can easily find that value. So 2x minus, 48? Wow. Plus 9x equals -4. Combine 9x, 2x, I got 11x minus 48 equals -4. Adding 48, and now you can kind of see where this is going. 11x equals 44. X is 4. That's, again, half of an answer. We have x. Well, the third step told you now to take that answer and put it into the revised formula or revised equation from here. You have x, you need y. Well, there's y that you need. Just stick this x into here, solve away. So here we go. Y equals 16 minus 3. Now x is 4. So y equals 16 minus 12. And that gives me y equals 4. Hey, there you go. That's 4, 4. 4, 4 is where these 2 points, these 2 lines will meet. All right, good luck with the practice.